In mathematics, a function is a relation between an input value and an output value. These can be represented in form of an equation, like shown here, but often also as a visual representation in a coordinate system as shown on the right. In this video, we'll see at how to go from the expression to the visual representation. A computer will usually do that by inserting a lot of different x values and compute the associated function values and simply add that to the plot. And that can be many points, which works really fine, but we have an issue in doing the same thing as a human because it's not fun to evaluate 200 function values and so on. So usually we want to do it with a much lower number of points. In this case, 5 points. If you plot that into the coordinate system, you can actually sketch out a straight line and see, okay, that is the equation of the expression. We can also be a bit more concerned about finding good points that tell us something about the function. In this case, we can try to insert x equals 0 or locate where the function intersects the x-axis. And this gives us these two axis intersections, and we can use them to again draw a straight line between these two. To be a bit more generic about this type of expression, we can look at the meaning of the a and b value in the expression a times x plus b, where a is the slope of the line, which means that if you step 1 unit along the x-axis, how much will the function value change in that on the y-axis. And similar for the b value, which is the intersection of the y-axis. So given these two numbers, if you can recognize the expression, you can actually sketch the line just by knowing this without having to plug in additional values in the equation. We can also try to look at a bit more difficult expression. This is a quadratic function, and by taking the derivative, we're able to determine the slope of the function at different points. So here I inserted 3 different x values and computed both the function values and also the derivatives of these points. And we can plot them in a coordinate system like this, and also add indicators for the slope of the function at the different locations. And using these as a guide, we can actually sketch the function based on the equation and these helping points. The same approach can be used if we want to sketch this function sine of 2 times x. Again, we compute the derivative and locate a number of points where we can insert into the equation. I tried to locate some points where the function or its derivative will have the value of 0, because these are interesting points that helps us sketch the function with a low number of points. So here we insert the points, and again this slope indicators, and based on that we can actually sketch the function quite nicely using this. So let's look at a more difficult example. This is a rational expression consisting of x divided by x squared plus 1. And we can look at 2 regimes of this. The first one is when x is much less than 1. In that case we can get rid of the x squared term in the denominator. And we can also look at what happens for x much larger than 1. In that case the expression reduces to 1 over x. Both of these expressions can be added to the plot, and we get these 2 helper lines that will actually help us sketch the function. In addition to that, I have inserted x equals 1 and x equals 2 into the expression, and that allows me to sketch the function here. Similarly, we can approach this rational expression with minus 2x plus 2 in the numerator and x plus 2 in the denominator. The denominator gets to 0 when x equals minus 2, which is a vertical asymptote. We can also do polynomial division to obtain this equation here, where we get rid of the last fraction. These will also be 2 simpler expressions that can help us actually sketch this function. Now we can insert x equals minus 1, 0, 1 and 2 as points and see where they will be, and this is enough to actually sketch this function in a quite nice way. So these are different ways of actually visualizing a function given its expression. So if you want to do that yourself, try to locate some point pairs that match the equation. If you can locate some points of interest, well, we either have intersection of the axis or local minima maxima. That's really good. Sometimes it's possible to draw these slope indicators if you know the derivative of the function. And finally, especially for the rational functions, you can draw these asymptotes to also help you sketch out this. I hope this is beneficial, and have a nice day.